All right, we're going to go ahead and look at the second part of solving right triangles. And in this case, we're going to look at the second situation over here on the right where we know two sides. And a lot of the steps are similar. So we're going to locate the angle, in this case, that we want to find. Before we located the angle that we knew. This time we're locating the angle that we want to find. And then determine which two sides you know. So we're going to do two sides. And so we select two sides in this case. Before we selected one at a time. And then choose the ratio that deals with those two sides. Then we'll write an equation and solve. And we will have to do what's called an inverse trig ratio of both sides, and you'll see what that is. And then you'll find the other missing parts. So let's go ahead and look at this one here. I'll try to get the steps on at the same time, at least to start with. So locate the angle you want to find. You actually have a choice here. You can find angle A or angle B. Let's go ahead and find angle A. So I want to find angle A in this case. And so I'm going to look at the two sides that I know. So here's angle A. I know the 11 and the 17. So the 11 compared to A is the adjacent leg. And then the 17, which I also know, is the opposite leg. So that was step 2, just thinking of those two sides that we had. Sometimes we might know the adjacent leg and the hypotenuse, or the opposite leg and the hypotenuse. But in this case, we knew the adjacent leg and the opposite leg. And so we think now we're in step 3, choose the ratio that deals with those two sides. So which ratio deals with the adjacent and opposite? So remember, so ka toa. This sine is opposite and hypotenuse. Cosine is adjacent and hypotenuse. Tangent is opposite and adjacent. So we want to use tangent. So we are going to write, now we're on step 4. We're choosing tangent. And now we're on step 4. So this was kind of step 1, step 2, step 3. Step 4, we're going to go ahead and write our equation. So write an equation using the trig ratio from step 3, so tangent, of the angle that we're referring to, which is A, equals, in definition of tangent, again up here, is opposite leg. So the opposite leg was the 17 over the adjacent leg, which was 11. So there's our equation. When you have two sides and solving for the angle, it's a little bit less steps. So we need to get A by itself. Well, just like if you had 3x equals 15, to get x by itself, you divide by 3, because 3 is multiplied by x. To undo multiplication, you do what's called the inverse, which is division. Well, there's an inverse to tangent, and you actually write tangent, and you put a little -1 there. That's inverse tangent. And I want to see you do this correctly. When you do inverse tangent, you actually make sure you put it to the left of the fraction. So inverse tangent, I know it's kind of squeezed in there. You do not do what's in blue here. You don't put inverse tangent after the fraction. You put it before the fraction. So this is incorrect. You don't want to put it like that. In fact, let's go ahead and erase that. And now we just use our calculator here to solve this. So on the left side, the tangent and inverse tangent cancel, just like in this equation, the 3 cancels with the 3. And so we're left with A. And now we have to figure out what's inverse tangent of 17 over 11. Well, we use our calculator. Notice in this row there's tangent, and right above it you see the inverse tangent. So you need to use the second key in this case. So inverse tangent. See how it's written up there in the calculator. And we want to do, it opens parentheses for us, so we want to take inverse tangent of 17 divided by 11. We close the parentheses, and then we hit enter. And so that angle A is 57.09. So angle A is 57.09. Now, find the other, so we did step 5. That's finding the first part. It usually takes the longest because we thought through all this stuff. Although once you get good at it, you pick out, oh, we need to use tangent right away. But now let's look at step 6 here. Step 6, find the other missing side using the Pythagorean theorem. Oh yeah, that's not new to us. So we know we're looking for the hypotenuse, which is c. So we can do 11 squared plus 17 squared equals c squared. So we got 121, 17 squared. Maybe you know what that's equal to. That's 289 equals c squared. We add 121 plus the 289, which is 410. And we take the square root of that. And we get c is about 20.2. And then lastly, we need to find the other angle. Well, we could have, so 6 and 7 can be switched. They don't need to be 6 then 7. We need to find the other angle, which is angle B. And that's very simple now because we know angle C is 90. Angle A is 57.09. And we can find angle B by subtracting. So angle B is going to equal 90 because the two acute angles have to add up to equal 90 minus 57.09. And you get 32.91. Now, when you solve these triangles, I don't think I mentioned this before, I would prefer you to put your answer, if you can, right on the triangle, because then you can see what everything is. So this is 32.91, and we found C with Pythagorean theorem, that was here, and that's 20.02. And that's actually in inches. So we solved that right triangle. We were given two sides, and we solved it. In this case, we use tangent. We won't always use tangent. It just depends on